All right, Algebra 2. These notes are thorough, and I am going to basically teach you what this is. You are responsible for these rules. I know it seems overwhelming, but it's not that big of a deal, and the more you practice this, the more these rules kind of stick. These are like mathematical rules I have memorized from ever ago, and it's just because, I don't know, they never kind of go away. So with that said, I'm going to go ahead and start by saying when you look at these notes, right here, this is a reference sheet. It's kind of hard to teach you everything going on in math by just looking at this. Even as a math teacher, I struggle to break this information down into something meaningful. So make sure that you don't stress out about this. Just understand that this is here for you to come reference later. So let's go ahead and start what we're talking about here. Let's just go ahead and do a main lecture. So this is a lot, right? These notes are a little busy, and that's okay. So I'm going to go ahead and start by talking about what each of these little incidents or these little rules mean. So the multiplication rule. Let's go ahead and look at that. The multiplication rule. What do we mean by this? All right, what we're dealing with is exponents and the rules of exponents, basically. So here we go. I'm going to talk about what I mean by this first rule. So this first rule, multiplication rule. Here we go. Multiplication rule. What does it mean? Well, it means this. If I have x to the 4 times x to the 3, that ends up actually being x to the 7. Do you see that? Instead of an a, I have an x down here. These are just placeholders, right? So x to the 4 times x to the 3 is equal to x to the 7. We've been doing that. So we have that down. That's not that big of a deal. You can see it as well, too. So for instance, if I said, hey, 3 squared times 3/3, you'd end up with 3 to the 5th. That's what you'd end up with for those. So that's how that works. Let's go to the division rule, B. I don't know why I circled that. Let's go to B. Okay, what does this look like? Division rule, it's simple. If I have x to the 4th divided by, let's say by x to the 1, what you end up with is you do minus instead. This is 4 minus 1. It ends up being 4 minus 1, which gives you x to the 3rd. So now let's set it up the way we actually set up division in real math. We set it up like this. So how does this work? When it's set up like this, you take all the exponents up here and find the bases down here and match it. So this is an x, this is an x. 4 minus 1 is equal to x to the 3rd. Now, I'm going to show you another little thing as well, because it's important. If I had x to the 1 over x to the 4th, the rule is the exact same. The rule is the exact same. You're going to start on the top. This is 1 minus 4. 1 minus 4. Well, 1 minus 4 is x to the negative 3. Now, we typically don't like negative numbers in our exponents. In the real world with STEM, you can use negative exponents. It's not that big of a deal. But as far as pretty math goes for people, we want you to do something with this. So what do I want you to do with this? Well, we'll come back to this in a second. I'm going to underline this thing so we can talk about this in a little bit. There's a special rule that comes around when you have a negative exponent, and it's pretty simple. So that's that. Remember the rules for division. Subtract this exponent minus exponent. Same thing here. This exponent minus this exponent, and you're good. So now I'm going to go to the rule C. I circled it again. Get it together. Rule C. Okay, rule C. The power of a power rule. This is what they mean. When you have x squared raised to the power of 3, the rule is you're going to multiply those two things together. You multiply those things together, and you end up with x to the 6th. You end up with x to the 6th. It's pretty simple. It makes a lot of sense too. Why? Because let's think about it. This is saying we want you to do x squared, but do it 3 times. X squared times x squared times x squared is equal to x to the 6th. Is equal to x to the 6th. So that's why this comes from there. Make sense? I think so. Now I'm going to talk about the product rule here. The power of a product rule. What does that mean? Well, let's say you had 4x. I'm going to put D up here. Let's say you had 4x squared. Let's say you had 4x squared. This means you're going to square both of them. So this would come out. You see how this is done? The power of a product rule. You see the parentheses? It's basically saying you're going to raise this up to the exponent just like this. So this comes out to 4 squared times x squared, which ends up coming out to 16x squared. That's what those rules mean. So now let's check out the power of a fraction rule. It's not that big of a deal. If I was on E I mean, if I was going to step E, if I had this, I'm going to do, let's see, x to the, I don't know, I'll just do x over 4. Let's do that. And if I raise this, x to the 4, if I raise this up to a squared, it'd be the same thing as before. Each of those things gets a square in them. So that ends up being that. And then you end up with x squared over 16. So that's what that rule means. You can also do it with letters. Let's say I had x to the 2 over y to the 3, right? But then I'm squaring this whole thing. That looks like a 1. That's a 2 right there. And let's say I'm squaring this whole thing. So what ends up happening here is I end up with 2 squared, so 2 to the 2. I'm going to multiply those. I get 4. And then I'm going to have 3 raised to the power of 2. I'm going to get 6. So that's how that rule works. 0 exponent rule. I'm going to scroll down a little bit. The 0 exponent rule basically means anything raised to 0 is equal to 1. Anything. If you have, let me write f here. If you have this rule, f, if you have, let's say, a to the 0, it equals 1. If you have x to the 0, it equals 1. If you have, I don't know, 3,000 raised to the power of 0, it equals 1. That's that. There's a reason for that. It's actually a mathematical trick. I'm not going to get into it, but there are some cool videos on YouTube that talk about why raising a power to 0 is equal to 1. It's interesting for those who want extra. Negative exponent rules. Now, I'm going to go back to where we talked about earlier. I'm going to switch to red. I'm going to switch to red where I talked about I'm going to come back to this negative exponent at some point. I'm going to come back to this negative exponent at some point. And here's the rule. It's very simple. I'm going to start with x to the negative 3. The rule is this. In order to get rid of exponents, all you do is you move the entire term to the bottom. What does that look like? We'll pretend this is a fraction, because it is a fraction. What ends up happening is this moves to the bottom. And when it moves to the bottom, and there's nothing in quotations on top, what ends up happening is there's a 1 that's in its place. So same thing as well. Let me show you another one. Let's say I had, let's do 2 over x to the negative 3. Let's say we had that. We had 2 over x to the negative 3. This means you're going to move this to the top now. So this one, it meant move to the bottom. Really what it means is switch places. Just bring it up. In order to get rid of that, just bring it up. And we end up with 2x to the negative 3 on this one. Likewise, if I had something cool like this, if I did, I don't know, negative 2, no, I'll do y to the negative 4 over x to the negative 3. Well, what ends up happening? They both switches. This x goes up, this y goes down, and you end up with x to the 3rd over y to the 4th. So again, these are rules you have to memorize and use. They're not that bad. This one right here, the fractional exponent. This is going to be its own thing that I talk about. Yeah, I'll go ahead and do a quick dive on it. I'm going to switch to purple for this one, the fractional exponent. What does this mean? I'm going to show you what this means. H. What this means is this. If I said, let's say I had the square root of x. Remember, technically there's a hidden 2 here, and remember, technically there's a hidden 1 here. We will rewrite this like this. This becomes rewritten as x. Everything that's inside the house gets rewritten as x to the 1/2. Where did that come from? See that 1 inside the house? See that 2 outside the house? That's how we write this with the exponents up there. These are called fractional exponents. Let me give you an example of another one. If I had the cubed root of x squared, you could rewrite it like this, x to the 2/3. You could rewrite it as x to the 2/3. Okay? So that's the basics of this stuff right there. This is the main lecture. You will have to power through this. This is kind of an annoying, boring lecture, but you've seen how these rules work now, and I can't stress you enough this order. Once you figure out how to rewrite fractions like this from here to here, it's kind of cool what you can do with it. So with that said, this is going to be the main lecture, and then I'm going to go show examples.